This will be a round 2 question. Let's assume that BM is X, BN is Y, and PC is Z. So OM will be Y again. This will be X. This will be 6 minus X. Now you can see that OMA is similar to ABC. So we can say Y upon 6 minus X is equal to 4 upon 6. And similarly, BON is similar to BPC. So we can say X upon Z is equal to Y upon 4. So using these two equations, we can calculate that X is equal to 12 minus 3Y upon 2, and we have to maximize X into Y. So X into Y is nothing but 12 minus 3Y upon 2 into Y, or it will be half of, take minus common, minus half into 3Y square minus 12. Now if you have to maximize this part, you have to make it a perfect square, right? So make it as minus 3 by 2, let's take it common also. It will become Y square minus 4. It has to be Y. So Y square minus 4Y. Right, now if you have to make it a perfect square, you have to add 4 to this, so that it becomes a Y minus 2 whole square. Now you are adding 4 to this, which is basically equal to, when you open this bracket, it will be minus 3 by 2 into 4, which is nothing but minus 6. So actually you are subtracting 6, so I have to add 6 in this. So now this becomes minus 3 by 2 into Y minus 2 whole square plus 6. So you have to maximize this part. This will be maximum when this part becomes 0, because it's a negative part. So when Y equal to 2, at Y equal to 2, this part becomes 0. That means maximum value of X into Y will be 6. So Y has to be 2 in that case. And we can find the value of X also. X will be 3, and Z will come out to be, from this, 6. Z equal to 6 means this point has to be coincident with D, because AB is 6, DC is also 6. So P has to be on D. So maximum length of DP will be, the length of DP in that case will be 0. Hence the answer would be D, none of these. Option D.